It says for example number 7, it takes 10 newtons of force to stretch a spring 2 meters beyond its natural length. So I have a spring, and it has an object on it, and to move it 2 meters, it requires a force of 10 newtons to kind of stretch that thing like this. Okay? And so now what we want to do is says how much more work is done in stretching the spring to 4. So what we want to do is we want to go to 4. So how much work would that be? Okay.
Work is done out of budget.
Watch that video.
No, but I will review how we calculate the relationship between work and force, right? And so Hooke's law is F is equal to K times X. And so remember that work is equal to the force times the distance. But if we think in terms of X, like this is like the XY plane, where this is 0, this is 2, and then this is 4. Okay? Then really it's force times X. Right? That's Hooke's law. Okay?
Oh, okay.
So what we want to do is we can go back and calculate what K is. How do we calculate what K is? Well, K is the constant of the spring. So if I say F is equal to Kx, and we're told that 10 is the force required to move the object 2 meters, then we get the constant of the spring is equal to 5. Does that make sense? So then my function of the spring is 5x. That's the amount of force that's applied. Wait, I gotta think this through here. Oh, but I've got 2 forces up there, so let's erase this before I confuse you guys. But we know that work is equal to, let's say, the force of the spring times x, and I just said that the force of the spring was what? 5x times x. Wow, that's kind of hard to do. So what I need to do then is I need to come down here before I really get confused and just know that what would be the force? How much force would be required to move it to 4 meters? Well, the force is equal to K times X, or in this particular case, the constant of the spring is 5. So the force required would be 5 times 4, which would be 20 newtons. Okay? But what's the question they're asking us? Work. So I go from 10 newtons to 20 newtons. Now, if I want to know the exact amount of work, if I were to measure the force over distance, we would get something like this. Okay, this would be my distance x, and this would be my force, which is 5x. If I move it 0, if my force is equal to 5x, and I haven't moved it at all, what's the force being applied? 0 newtons. So I've got this point here, which is 0, 0. Then at 2 meters, I've got 10 newtons. At 4 meters, I've got 20. But we said work is equal to force times a distance. Well, this is technically a varying of force, right? This line represents the force over time, or over distance, I should say. And then this value right here represents the distance. What's another way, when you think about it, what does this force times distance represent? No. Work. But look at the graph. What on the graph does that represent?
Height.
The area under the curve. So what that means is to find the area under the curve, I'm going to have to go from, where are we starting from?
0.
Well, the question is worded very specifically, how much work needs to be done to slide it to 4, and we can assume we're starting at 0. Okay. But we know that this function is 0 to 4 of 5x. So that's not that hard to do. We can figure that out. That would be 5x squared all over 2, evaluated from 0 to 4. So I've got 5 times 4 squared all over 2 minus 0 squared times 5 all over 2. This cancels, or it goes to 0. So I've got 16 times 5 over 2. 16 goes into 2 8 times. 8 times 5 is equal to 40. 40 Newton meters. That's how much work was done. Does that make sense? How could I verify that, you guys?
Plug and show.
Kind of.
Trust you.
Could you do that?
Adams, I trust in you. No.
At the FN, you can plug it in and have the calculator tell you.
Exactly. What do we plug in though?
They into F2 to 4.
Yeah. Wait, you're absolutely right.
5x.
Yeah, 5x. That's it. Yep, that's it. That's what I was looking for. So what she's saying is if I want to double check it, remember we're pretty confident in our ability to do calculus at this point. Right? We should be. It may not feel that way. But now if I graph that, guess what I have? I have that graph I just drew for you guys. I'm going to change the window because we know that y goes all the way up to 20. So I'm going to change that real quick. And now I'm going to graph it. Whoops. Dang it. There's a little lag on the board because I'm recording and using the emulator at the same time.
Maybe I got through.
No, you didn't.
Maybe I hacked it.
No. And so what we're looking for is the area under the curve from 0 to 4. So if I hit second trace, it pulls up my calculate menu. Hit 7, that gives me the area under the curve. I'm going to go from 0 to 4. Now one other, let's say you're not impressed with that. Does anybody in here know what this geometric shape is? Triangle.
Right hand triangle.
If this is 4, 20,
I saw
Right.
something. No way. It would have to be.
what's this distance from here to here?
4.
What's this distance from here to here?
20. It's lit.
What's the area of a triangle?
Half times height times base.
1/2 of 4 is 2. 2 times 20 is
40.
We did great.
Hey, don't applaud yourselves yet.